All right, let's get right into it, because what we're talking about today is a genuine breakthrough for AI. We've all gotten pretty used to what artificial intelligence can do, but one of its single biggest limitations, it's just been completely shattered. So today, we're going to break down how researchers have given AI a new superpower, a powerful long-term memory. But first, let's start with a problem that I bet you've experienced yourself. Have you ever tried to get a chatbot to remember what you talked about just 10 minutes ago? Or maybe you've tried to get an AI to analyze an entire book or a super complex legal case? It just can't do it. That's because, until now, most AI has had the memory of a goldfish. It really struggles to hold large amounts of information in its head all at once. Now, this isn't some bug or an accident. It's a fundamental challenge that has defined AI development for years. For the longest time, the entire community has been stuck grappling with this core trade-off, a real dilemma when it comes to building these powerful models. For a long time, AI engineers were basically stuck between a rock and a hard place. On one side, you have transformers. That's the powerhouse architecture behind models like GPT-4. They are incredibly accurate, but that accuracy comes at a crazy high computational cost, especially when you feed them long streams of information. On the other side, you've got models like RNNs. Now, these are built for speed and efficiency because they compress information as they go. The problem? That very compression makes them, well, forgetful. So the choice was always smart but super expensive or fast but kinda dumb. So how do you get the best of both worlds? Well, the breakthrough came from a surprisingly intuitive place. Researchers started asking, what if we could teach AI to remember more like us, more like a human? And this quote just nails the core idea. Think about your own day, right? You don't remember every single step you took on your commute to work, but you would absolutely remember if a marching band suddenly crossed the street in front of you. We remember the surprises, the things that break the pattern. The key was to give AI that exact same ability. To really get this, let's use a little analogy here. Imagine an AI is processing thousands of pages of a very serious, very dry financial report. It's just numbers, charts, and predictable corporate speak, over and over again. And then, all of a sudden, buried on page 742, it finds a picture of a banana peel. That is completely unexpected. It doesn't fit the pattern at all. A person would immediately notice and remember that weird little detail, and now AI can do it too. This whole idea is formalized in what's called the surprise metric. It's basically a mathematical way for the AI to go, whoa, hang on, this is different. When new info is drastically different from what the model expects based on its current memory, it flags that info as important and shoves it into long-term storage. All the boring routine stuff, it just lets it go. So how do you take this cool surprise concept and turn it into actual working technology? Well, the answer is an architecture called Titans, and it's what puts this whole idea into practice. The way Titans works is actually beautiful. It runs on this simple 4-step loop, all happening in real time. First, it ingests new data. Then, it asks that key question, is this a banana peel or is it just another boring number? If it's a surprise, it updates a special deep neural network. That's its long-term memory. But if it's just more of the same, that information is simply discarded, which keeps the memory lean and efficient. But it gets even cleverer. Titans has 2 more tricks up its sleeve. The first is momentum. After seeing that banana peel, you'd probably want to know why it was in a financial report, right? Momentum makes sure the AI captures that important follow-up context. The second is forgetting. Just like our brains, it can't store everything forever. This adaptive gate is like a cleanup crew, tossing out old, irrelevant memories to make space for new, important ones. Okay, so Titans is a powerful new tool. But what's truly revolutionary here is that the researchers didn't just build one tool. They created the entire blueprint. It's a framework called Miras, and it gives everyone a whole new way to build AI with powerful memory. Miras completely reframes the problem. It basically says that any AI that processes information in a sequence can be defined by these 4 key choices. It's like giving engineers a universal recipe book. Instead of being locked into just one design, they can now mix and match different memory structures, attention systems, forgetting mechanisms, and update algorithms to create totally new and powerful systems. And this is a huge deal. Seriously, think of it like going from having a single wrench to having an entire toolkit. Before, developers were kind of stuck using one basic method to improve their models. Miras blows the doors open to a much richer design space, letting engineers experiment with all these new, sophisticated ways for AI to learn, remember, and forget. And that leads to way more robust AI. Okay, so the theory is fantastic, but does any of this actually work in the real world? Let's get to the payoff and look at the absolutely stunning results from putting these new models to the test. And the answer is a massive yes. Titans was able to handle a context window of over 2 million tokens. Now, a token is just a piece of a word, so to put that in perspective, we're talking about the equivalent of reading the entire Harry Potter series several times over and remembering the details from start to finish. It is a gigantic leap in scale.
But it's not just about size, it's about efficiency. This chart shows a test designed to measure reasoning across extremely long documents. And look at this. Titans, which is a much smaller model with way fewer parameters, actually outperformed a massive model like GPT-4. This proves it's not just bigger, it's smarter about how it uses its memory.
And this success wasn't just in one area. The new models proved they were incredibly versatile, consistently hitting higher accuracy across a whole range of tasks, from normal language and reasoning to super specialized fields like genomic modeling and financial forecasting. So, the big question is, what does this all mean? An AI that can effectively learn on the fly and never forget the important details, that's not just a small improvement, it fundamentally changes what's possible. This breakthrough unlocks a whole new universe of applications. Imagine a legal AI that doesn't just search keywords, but reads and understands an entire legal library to find that one obscure precedent that wins a case. Or a medical AI that analyzes a person's complete DNA sequence to spot disease markers years in advance. We're also talking about truly personalized assistants that remember every conversation you've ever had, and way more powerful models to tackle huge challenges like climate change. This quote from the researchers really says it all. This work finally combines the speed and efficiency of those older models with the accuracy and power we need for the next generation of AI. It finally solves that old dilemma we talked about at the beginning and kicks off a brand new era of long context AI. Which leaves us with one final fascinating question to think about. We've just taken a massive step toward an AI that can remember, synthesize, and reason over unbelievable amounts of information. So, what will we discover when our most powerful tools can finally remember everything?